Section 3.2 States and Properties of Matter. On Earth, matter exists in one of three states of matter: solids, liquids, and gases. A solid, such as a pebble or a baseball, has a definite shape and volume. You can probably recognize several solids within your reach right now, such as books, pencils, or a computer mouse. In a strong attractive forces hold particles together as atoms or molecules close together. The particles in a solid are arranged in such a rigid pattern that their only movement is to vibrate slowly in their fixed position. For many solids, their rigid structures form a crystal such as that seen in an amethyst. A liquid has a definite volume but not a definite shape. In a liquid, the particles move slowly in random directions but are not sufficiently attracted to each other to maintain a definite volume, although not a rigid structure. Thus, when water, oil, or vinegar is poured from one container to another, the liquid maintains its own volume but takes the shape of the new container. Gas. A gas does not have a definite shape or volume. In a gas, the particles are far apart and have little attraction for each other and move at high speeds, taking the shape and volume of their container. When you inflate a bicycle tire, the air, which is a gas, fills the entire volume of the tire. The propane gas in a tank fills the entire volume of the tank. Table 3.1 compares the three states of matter. Solids have definite shapes. Liquids take the shape of the container. Gas takes the shape of the container. Solids have definite volumes, liquids have definite volumes, gas fills the volume of the container. Solid has fixed arrangement of particles, liquid has random or close, and gas is random and far apart. Solid has strong interactions between particles, liquid has strong, and gas has essentially none. Solid has very slow moving particles, liquid moderately moving particles, and gas very fast. Examples of solids are ice, examples of liquid is water, examples of gas is a water vapor. Physical properties and physical changes. One way to describe matter is to observe its physical properties. If you were asked to describe yourself, you might list characteristics such as the color of your eyes and skin, or the length, color, and texture of your hair. Physical properties are those characteristics that can be observed or measured without affecting the identity of a substance. In chemistry, typical physical properties include the shape, color, melting point, boiling point, physical state of substance. For example, you might observe that the penny has a physical properties of round shape, an orange-red color, a solid state, and a shiny luster. Table 3.2 gives more examples or physical properties of copper found in pennies, electrical wiring, and copper pans. Water is a substance that's commonly found in all three states: solid, liquid, and gas. When matter undergoes a physical change, its state is appearance changes, but the composition remains the same. The solid state of water, ice or snow, has a different appearance than the liquid or gaseous state, but all three states are water. The physical appearance of a substance can change in other ways too. Suppose that you dissolve some salt in water. In the solution, you would no longer see the salt, but you could taste it. However, you could reform the salt crystals by heating the mixture and evaporating the water. In a physical change, however, there are no new substances produced. Table 3.3 gives more examples of physical changes: boiling water, freezing water, dissolving sugar, hammering gold, drawing copper into wire, cutting paper into confetti, grinding pepper into small particles. Chemical properties and chemical changes. Chemical properties are those that describe the ability of a substance to change into a new substance. When a chemical change takes place, the original substance is converted into new substance, which has different physical and chemical properties. For example, the rusting or corrosion of metal of such as iron is a chemical property. In the rain, an iron nail reacts with oxygen to form rust. A chemical change has taken place. Rust is a new substance with a new physical and chemical properties. Table 3.4 gives examples of some chemical changes. Tarnishing silver, burning wood, caramelizing sugar, or forming rust are all chemical changes. Table 3.5 summarizes physical and chemical properties and physical and chemical changes. A physical property is a characteristic of a substance, such as its color, shape, odor, luster, size, melting point, or distance. A physical change is a property that retains the identity of a substance. A change in state, a change in size, or a change in shape without changing its substance. A chemical property is a characteristic that indicates an ability to form another substance. Paper can burn, iron can rust, silver can tarnish. A chemical change is a change in which the original substance is converted into one or more new substance. Paper burns, iron rusts, silver tarnishes.